we add pure distilled water into it, right? Okay. The scissors. Then we have sodium chloride. Why are we adding sodium chloride? I just explained. Who knows? Who knows? To increase the conductivity of electricity, right? So we are adding. Okay, enough. Now we have formed two electrodes, one anode and the other one cathode. So we'll put it in water. Make sure they are not touching each other. Now, do you see here? Sure. I don't know if you can see it there. It has started to produce bubble. It has already started electrolysis of water. The hydrogen, it will on anode. The reaction will be oxygen. Two water molecules will be broken down into two molecular oxygen and two molecular hydrogen, and then oxygen will evaporate from here from anode, and then on cathode the hydrogen and it will combine with four excessive electrons, and then it will start flowing. So both will start flowing from here, and we are collecting it in this jar, and from here it can be inhaled directly. Obviously this is very low voltage, and we are producing only 100 to 200 millimeters per hour from these two plates. So in atoms we are still working, and we want to make bigger plates for this HHO pump. So I'd like to touch on my last slide. Is it clear? You see the electrolysis, right? So what are our future perspectives? Why are we doing this, right? The first one is we want to invite people with acute asthma to come on weekly basis and inhale HHO for at least an hour. Then we want to measure their pulmonary function test PFTs prior to the beginning the trial, and weekly measuring PFTs. Then we want to compare their PFTs using complex statistical formula to find any correlation between improvement of health by inhaling HHO. Then after a positive correlation is found, trials will then be conducted on chronic smokers to increase the impact of HHO on their health. Then after effective preliminaries on smokers, then we will move toward patients with acute infectious diseases and then chronic infectious diseases. We are also researching on blood's capacity for carrying HHO to distant sites in the body, so that HHO can be used by inhalation pathway to target and treat infectious pathologies affecting organ systems other than respiratory system. Next one. Next one. If anyone has an asthma, or are they chronic, or maybe even acute smokers, feel free to participate on our clinical trials. We would really appreciate that, and feel free to contact me via email. I've already written a complete research article on this topic, and if you want to read this, email me, I'll send you directly. The next one. Any questions related to? Yes, sure. Yes.
Imran, basically when I listen the whole theme of your presentation, you are going to represent the idea of how we can squinch the ROS,
Yes.
which is generated in the body when our body is suffering from the any kind of the stress.
Yes.
So why we are using this HHO? I can get the whole concept that it produces the hydrogen or it inhale. But when the normal human body or the any plant body or any microbial body goes under the stress, there is the natural mechanism.
Yes.
For example, the production of the antioxidants enzyme,
Yes.
enzymatic plus non-enzymatic antioxidants. So these antioxidants naturally can sequence the ROS.
Yes.
So why we are using this?
Before starting my presentation, I already talked that we are talking if ROS are produced in excess amounts, right?
But let
Yes.
me correct you. For example, if ROS generating the large amount
Yes.
or maybe produced beyond the limit.
Yes.
So what is the first enzyme which is produced in the human body or it sequence the ROS?
According to my knowledge, it is glutathione reductase,
No.
which reduces NADPH to NAD positive to NADPH, and it then
This is the mechanism of the enzyme. But according to the classification of the enzymes, the superoxide dismutase,
Yes, that is
which is also called as the
yes.
SOD. So first of all, SOD produced within the human body.
Yes.
SOD convert hydrogen peroxide into the water because hydrogen peroxide plays a very bad role. It will disturb the electronic configuration of the normal cells. So SOD, after the SOD, then catalase, then glutathione. This is a basic sequence.
Yes.
So SOD is the more powerful
Yes.
enzyme. Or if we can also maybe this procedure, what is the critical point of this procedure or this research? The drawbacks.
The drawbacks, there are still no clinical human trials. We have only done theory, and we still.
But we cannot, according to the science, we cannot apply anything directly to the human life because human life is very precious. So how you can administrate this directly? You are applying the electrolysis of the water. You apply the electrical current, and then you at the last of your presentation you said you take the pipe or you can say the patient to inhale it directly, but it causes the injury to the normal cells or the tissue level. So what is the answer of this?
We are not directly applying it on human bodies. Can you move to that? Yes, this is bibliography. There are all the research articles that have gone through, and they have already worked on human application, and they have already done human trials. We are talking
If
about
they
this
have
for
already
that, right?
done this work,
Yes.
then what is the novelty of your work? Why we would repeat it?
Because
If
they
the
still
literature
not.
is already contain the material with so many similar researches.
Yes, because they still have not gone through asthma and COPD patients, and
No,
they still haven't.
let me give you the references. If you search in the Taylor and Francis PubMed, you can find a lot of studies with the multiple disease. We can apply the different kind of the procedures. So, but I just want to suggest you one thing. In the near future, the mostly medical scientists, they are working to enhance the expression of different enzymatic antioxidants.
Yes.
For example, SOD or POD or PPO, catalase, or maybe we can give the secondary metabolites from extract from the plants or the microalgae, which is flavonoid, saponin, alkaloid. So these the natural things which have less cytotoxicity, less hemolysis, so they are more appreciable or the useful techniques or the research treatment to treat with the ROS.
Yes, our main idea was because when we put patients on ventilators, right? The high pressure oxygen, it depresses your medullary brain centers, right? VRG and DRG. So our main aim was that if we give it in combination with hydrogen, 33% of oxygen it will be sufficient enough to sustain life, but it will not be sufficient enough to
But if you
depress our medullary
simply
brain.
for example, just like if I will give you the example of the diabetes patient.
Yes.
So we can synthesize insulin outside the body. So we administrate the subdermal injection of the insulin. It will control the glucose level of the patient. So why we are not going towards the biotherapeutics or the biomedicine?
There are different ways to treat the same disease, right? You agree, right? So this is one of the ways. Your way is also right.
But according to my point of view, we must have to be required more clearance of the concept or the knowledge.
Yes.
Because ROS when we specifically talk to the ROS, the reactive oxygen species, then we must be increase the expression of the superoxide dismutase, or we will administrate the superoxide dismutase artificially to the
Let's suppose
humans.
we want to increase the reaction of superoxide dismutase.
Not reaction, expression.
The expression of superoxide dismutase, right? So there are also bacteria. They also have their some sort of bacteria right? So what if they also start increasing their own expression of superoxide dismutase as well? How do we overcome that problem?
But there is a lot of the
How would
microbial.
how would it be able to? Does anyone have any other questions?
Thank you, Mustafa, for moderating, and thank
Good.
you so much,
Very good.
Abir, sir, for sharing your insight on this topic with us.